My name is Adriana Kovashka from University of Pittsburgh, and today I'd like to share my group's work on reasoning about complex media using weak multimodal supervision. The motivation for this work originally was common sense reasoning before it became popular. Common sense, and it turns out, is really challenging, but it is also very important, especially for the two domains we consider, advertisements and political articles. Both of these rely on associations that humans make to convey their message. Their rhetoric depends on multimodal context, namely images and text, and we focus on how to parse this context. However, different than most work on image and text interactions, in our case, the channels are complementary, not overlapping. Each channel provides weak supervision for understanding what the other one shows, and here we aim to use this weak supervision to learn models for a variety of tasks, even if the supervision is noisy. I will describe our work on reasoning about advertisements, cross-modal classification and retrieval in political articles, and weakly supervised object detection. First, the motivation for our work on advertisements specifically. There's plentiful evidence that media shapes opinions. For example, the top left image is said to have changed the course of the Vietnam War because of how it portrays the South Vietnamese general on the left. The picture at the top right changed the face of AIDS. At the bottom left is a well-known early ad, and on the right are three especially creative ads from Absolute Vodka. Please take a moment to think about why the text in each is what it is and what clues the image gives, such as the absolute appeal. We find that state-of-the-art vision systems are inadequate to describe the messages hidden behind purposefully designed advertisements. For example, the concepts or objects that are recognized in this ad are correct, such as people, commerce, as well as image captioning is reasonable, such as a man is standing in front of a display of food. However, they completely miss the point of this ad. In terms of what it means, we find that a human might annotate this ad as food at Burger King must taste really good, since even a competitor's employee secretly buys it. The goal of our work is to allow a system to automatically provide the what it means explanation. Of course, automatically analyzing ads is very challenging. Some of the challenge is due to ads featuring rather creative, atypical objects like the trash deer, fruit cow, tree lungs, and coffee owl shown here. Second, ads often feature physical processes that are just implied but required for understanding. For example, in the top left, the earth is melting. At the bottom right, the bear is being crushed by the arm of the clock. In other words, its time is running out. Third, ads feature content that implies deeper meaning beyond the surface. For example, cigarettes symbolize danger, China symbolizes fragility, and an oven mitt symbolizes heat. Finally, and this is something that will be hard to make progress on for a while, ads require cultural knowledge, such as having seen the heavy metal sign or the flag of Italy at the bottom right. The outline of this talk is as follows. First, I'll talk about work on advertisement understanding, starting with a dataset we release, our main task of predicting what the viewer should do according to the ad and what arguments the ad provides for taking the suggested action. I'll talk about a few related tasks, such as understanding the relation between image and the slogan, personalization and generating faces and ads, and finally a spin-off task of weakly supervised object detection from captions. Then I'll briefly describe our work on understanding political articles. Specifically, we aim to predict the political leaning of a media source based on its photos alone, as well as retrieve sentences from an article given an image and vice versa when the image-text overlap is limited and abstract. We pose advertisement decoding is predicting what message the ad conveys, which we call the action, and what arguments the ad provides for taking the suggested action, which we call the reason. Because the task is challenging, we formulate it as a multiple choice task. As an example, here are three options for this image that humans wrote and that would be considered correct, such as I should drink Evian because it helps you recover. To enable this, we first create a large, diverse dataset of over 64,000 images with annotations encompassing over 40 topics, what is being sold or what problem the campaign is about in the case of public service announcements, as well as the sentiment provoked in the ad, the action reason statements, and so on. We also make available a smaller companion video dataset. One approach we proposed in PAMI 2019 contains 4 branches, each of which represents different aspects of the image. First, we represent image regions, combined using importance scores. Second, we encode slogans embedded in the image, extracted with OCR. Third, we train symbol classifiers and represent the image with a distribution over the symbols represented, such as danger and nature for this image. Finally, we use a pre-trained method to extract captions for regions of the image that is a proxy for having object annotations. All of these are combined and projected into a 200-dimensional space. We then use metric learning to bring the 200-dimensional representation for the image close to that for a corresponding action reason statement. For this image, we want a statement like, I should be careful on the road so I don't crash and die, to be close, while one like, I should buy this motorbike because it's fast, to be further. With a prior version of this approach, which only uses image features and symbols, we outperform prior cross-modal retrieval approaches. We qualitatively show that our method captures the rhetoric of the image correctly, even in purposely confusing ads. For example, in this ad, with green boxes denoting predicted regions of importance, it appears that the woman is putting on lipstick, but on closer inspection, we see that lipstick is a cigarette. Thus, the correct action reason statement to retrieve is, I should stop smoking because it doesn't make me pretty. Next, we show results that incorporate text from slogans that are part of the image. We see that slogans alone are more useful than images alone because action reason statements contain much closer connection to the slogans. In other words, the slogans more directly state the message, while the image by itself is more ambiguous. Predicting reasons is more challenging than predicting actions individually. And finally, we observe that on action reason statement prediction in video, speech in the video, which is an analog to slogans in images, is less useful than the video frames themselves. In ongoing work, we're exploring how understanding of ads can be improved by contextualizing these ads through knowledge bases. To enable this work, we first represent the image through a graph over regions and slogan words. We then use slogan words to query a knowledge base and represent the return knowledge nuggets in the graph as well. Not all of the nuggets are relevant. Here, 3 statements are retrieved for the Nike goddess, Nike the asteroid, and finally Nike shoes, which is the only relevant one. Partly due to the challenge of finding relevant nuggets, we observe that simply linking to knowledge graph nuggets doesn't mean the network will use those. It can easily find shortcuts that bypass the need for such knowledge-based reasoning. For example, in our dataset, the method can match Nike in the slogan to Nike in the answer options without understanding anything about the properties of these shoes. However, this shallow match is not feasible for a rare company, so the properties of the product must be analyzed there especially. Thus, we propose an approach to prevent overfitting, which is similar to dropout, but is done over the pieces of the samples, not the feature space. It's a masking approach, and it helps us use appropriate knowledge pieces. In more detail, we represent the image as a graph. Each slogan is represented through a basic embedding, but also by incorporating descriptions from external knowledge. The global image node is then composed of messages from region proposals and messages from slogans. In all of these equations, we have weights alpha and beta that are learnable and denote how much we rely on each incoming message channel, such as on external knowledge. We train with metric learning as before to retrieve appropriate action reason statements. We randomly mask aspects of the training data to prevent overfitting. In other words, relying too much on word level matching. This means that the system can now not rely on matching Nike in the slogan and action reason options, but has to reason about properties of the shoes which can be found in knowledge bases. We experiment with 3 masking strategies and ultimately combine all 3 in our experiments. We show that our method outperforms state-of-the-art. Importantly, we show that simply adding knowledge denoted by K to the visual V and textual or slogan domain denoted by T produces limited improvements because of the shortcuts and shallow matches between slogan and answer options that preclude the need to use a knowledge base. However, with our masking strategy, adding information from a knowledge base does help, and this is shown in the third row of each of these three groups in the bottom table. We improve results on the rank of the correct action reason statement as retrieved by the system. To better understand how our method leverages external information, we propose a small side task where we ask annotators to rate the possible knowledge-based nuggets for a given query, such as Nike, with respect to how relevant this nugget is for understanding the ad. We find that our masking allows our method to choose, through the alpha weights in the previous slide, statements that are on average twice as likely to be relevant compared to not using masking. Here we show edges in our graphs that have weight over 0.05, and we see that knowledge nuggets in orange are much more often utilized when masking is used on the very right-hand side of the slide. In other work, we explore the interplay between image and text and ads. Decoding messages involving visual rhetoric is very difficult since the exact same text can have very different interpretations under different contexts. These two ads both show the slogan Winter Collection, but the ad on the left is calling for preventing human trafficking, while the ad on the right is a typical clothing commercial. We have seen a lot of computer vision tasks that involve multiple modalities, such as image captioning and visual question answering. In these tasks, there is obvious alignment between the channels. For example, the shirt and guitar are present in both the visual and textual channels, and similarly for men and glasses. In other words, multiple channels are delivering repetitive or redundant information. In contrast, in persuasive and news media, for example, advertisements, the images and text employ different forms of visual rhetoric that compose in clever, non-redundant ways to deliver a more impactful message. In this example, the text mentions evolution, but on the surface, this has nothing to do with neither the dolphin nor the earphones, which are the main objects in the image. The topic of the ad is sound pollution, hence the need for dolphins to evolve into having earphones. To address this problem, we propose to detect the implicit relationship between image and text. We collected annotations and defined a taxonomy of relationships at different granularity. The most fundamental one is whether the image and text are parallel and deliver the same message independently. And parallel image texts are further subdivided into equivalent and non-equivalent, and both of the images here are parallel. We also found 3 reasons for image-text pairs to be non-parallel, for example, because image and text seem to contradict each other, such as in the top image, for larger effect, or one is ambiguous without the other, such as the middle image. We developed machine learning classifiers to predict the relationships. Our baseline is to use pre-trained visual semantic embedding models to project image and text into a common space. We also explored other intuitions. For example, if both channels can perform topic prediction independently, then the relationship is likely parallel, or if the images are creative or the text is abstract, then it's likely non-parallel. In another work, we learned to predict action reason statements in a viewer-specific way, accounting for personality differences captured through how a viewer looks at the ad. We just learn a metric space capturing content. In other words, whether a gaze map and an action reason statement refer to the same image, as well as a style space in the bottom right. This is capturing whether a gaze map and a statement were provided by the same annotator. And we also project viewer personality captured through a questionnaire in this space. Finally, we also propose a method for generating advertising content, specifically faces that would be fitting for a fixed ad category. We choose faces as the objects to model because their appearance varies quite a bit in different ad categories or topics, as shown here. For example, the faces for beauty versus domestic violence are quite distinct. Because our data is limited, state-of-the-art methods don't work well. Instead, we propose to model ad categories at the level of attribute distributions. Then we learn to generate images for each attribute from external non-ad specific data. So we will learn that domestic violence ads contain black eye and beauty contains red lips, and then learn to generate black eye and red lips with an external data set. We use a VAE where we insert an attribute modification vector to change the topic relevance characteristics of the face while keeping latent properties such as pose unchanged. We show a result here with hours at the top. While the results are somewhat blurry, content is more meaningful with respect to showing the ad category of choice compared to baselines such as start, GAN at the bottom. I will now describe an entirely unrelated project, which however evolved from our work on advertisements. Throughout our work, we discovered that we can detect associations between objects, image regions, and properties with weak supervision simply coming from the co-occurrence of images and action reason statements. For example, we find that in our metric learning space, the concept comfort is close to object words for pillow, bed, and blanket. We also can localize concepts such as Oreos and ketchup without associations beyond the action reason statements. This inspired an approach for learning object detectors from captions as training data. Our final approach relies on a text-only classifier, input captions into the system, and get pseudo-labels out at the image level. And this classifier requires very limited data. It's text-only data. We only need a few thousand samples from a single data set, and the results will generalize well across dataset boundaries. The challenge in learning from captions is that they don't mention all objects present, but they do mention words that are not immediately relevant. For example, in this example with tie is one of the ground truth objects, no captions mention tie, even though tie is a ground truth present object. On the other hand, the captions do mention plenty of other words. However, tie can be inferred based on lecture and suit being mentioned. Briefly, our results show that caption supervision can be comparable to training with ground truth image level labels, which are stronger. Other ways of mapping captions to pseudo labels are viable but inferior. And finally, our results generalize across datasets, meaning that whichever method works best on one dataset also works very well on a different dataset. Now, I'll switch gears and describe our work on modeling another type of media, namely multimodal news articles. We argue that it is possible to infer the political leaning of an article from visual content alone, because unfortunately, images show a biased view of people and concepts. We consider a multimodal setting at training time, namely images and paired lengthy articles. We first create a large dataset by crawling news articles. We get the left and right leaning label from the Media Fact Bias Check website. We assume all images from a media source have the same leaning for training, but we also request annotations on a small test set. Our approach to predict left and right bias involves two stages. First, we extract features and train a classifier to predict the left and right label using both the image and text modalities, and text is represented in Doc2Vec space, learned on our dataset. Then, with features extracted, we remove the dependency on text and fine-tune an image-only classifier. The first stage ensures much more stable training compared to not using text as an auxiliary or privilege modality. And briefly, one of our evaluation settings uses human labels for left and right bias, while our training data uses the labels of the source media. And in this evaluation, we group results by the type of image, and we obtain these types from human annotators, and show that our method works best overall. As a way of illustrating the visual variability in the data, we show the results of training a generator to exaggerate the following faces of well-known politicians and make them extremely left or extremely right-leaning. And I show the results here. Note that we required no human annotations. Here I'll show the original face, our imperfect reconstruction, then modifying the face to be coming from the far left but still preserve pose, and modifying it to be extreme right using our, and again, this all uses our crawled left and right sources and their corresponding images for these individuals. Note how different each of these politicians appears on the left and the right. In ongoing work, we're exploring how to improve cross-modal retrieval of images and text in these political articles, where the connection between image and text is much more abstract and relies on semantics much more than on appearance, or simple object presence. At the top, I'm showing image-text pairs from our politics dataset compared to traditional captioning datasets like COCO. At the bottom right, I more concretely show how the topic of immigration may be illustrated with a variety of imagery such as protests, children, border wall, which appear quite different visually. We propose a metric learning approach that grounds the similarity of images in the neighborhoods obtained from textual similarity. This means that we consider images in quadruplets of two neighboring texts paired with their corresponding images. And we enforce that the images with similar text project in similar places in our joint learned space. Note that this is not guaranteed in general because visually similar images are not necessarily semantic neighbors. We show that we outperform prior state-of-the-art on 4 challenging datasets. Qualitatively, at the bottom, we show that we keep semantically similar but visually dissimilar images close in our learned space, such as the European Union flag and Angela Merkel, and the images of a judge's gavel and the Supreme Court. And these are images that were most in need of being brought together because they were most distant in the baseline space as opposed to in our space. I'd like to thank my funding sources and my students who carried out this work. And I look forward to your comments and questions. Thank you.